On May 13, 2026, politicians in a single legislative sitting delivered 148 speeches. That's exactly 52,098 words spoken in one day. If you read that transcript top to bottom, you would understand the individual arguments, but human reading cannot process that volume to find macro patterns. To see the architecture of the entire debate, raw continuous speech must be broken down into queryable data. This text is the official record of the 27th Seanad, the upper house of the Irish legislature. The analytical challenge is taking this massive, unstructured linguistic block and extracting objective metrics. We need to know who is dominating the agenda, what rhetorical tools they are using, and how the actual debate diverges from the planned schedule. Extracting objective insight from modern political discourse requires abandoning human reading entirely. Instead, we run the text through a multi-tiered natural language processing architecture. This OIR research schematic passes raw transcripts through 3 filters: XML parsing, bare topic modeling, and spicy/Vader algorithms. This creates 3 structural data tiers: macro topic clusters, meso entities and sentiment, and micro-linguistic profiles for every speaker. A key mechanism here is named entity recognition, or NER. This algorithm scans the text to locate and categorize real-world proper nouns, like specific people, organizations, or geopolitical regions, without human tagging. By layering these models sequentially, the qualitative rhetoric of the legislature is converted into a highly structured mathematical topology. According to the official legislative record, this sitting was organized into 12 distinct XML sections, dictating a rigid and strict planned agenda. But this network graph visualizes bare topic embeddings, an algorithm grouping all 148 speeches into semantic clusters based on actual words. The Donit node is a policing cluster centered on Garda Síochána, absorbing 24 speeches. Secondary concentrations appear around turf cutting, insurance, and the Omagh bombing inquiry. That dominant cluster translates directly to debates over the resourcing and deployment of An Garda Síochána, the National Police Service of Ireland. The Omagh bombing node captures the historical weight of the debate, processing arguments regarding evidence, the Irish state, and international inquiries into the 1998 attack. The algorithm proves that legislative attention frequently bypasses the rigid structure of an official agenda. Politicians speak about what they want, and semantic clustering maps exactly where their attention goes. This bar chart visualizes the spacey NER model, categorizing proper nouns by person, organization, and geopolitical entity. An Garda Síochána dominates entirely, explicitly mentioned 128 times. Under geopolitical entities, the model reveals heavy geographic concentrations around Ireland, followed closely by Dublin and Omagh. However, the extraction is not flawless. The algorithm occasionally misclassifies entities, erroneously splitting mentions of the police force between the person category and the organization category. Moving past nouns, we can map the room's emotional temperature using the Vader sentiment algorithm. The mean compound sentiment for the entire sitting rests at a slightly positive 0.470. By calculating this score sequentially, we generate an exact map of the chamber's emotional volatility. The meso tier provides a quantitative footprint, telling us exactly what specific subjects occupied the room. We can drill down even further to the micro level, using descriptive statistics to generate a lexical fingerprint for every individual speaker. This radar chart plots a linguistic comparison of Senator Kelleher and Deputy Collins across 4 metrics. Kelleher's polydon spikes to extreme edges, averaging 108.1 words per sentence, at grade level 28.4. Collins registers a much tighter inner polygon, averaging 10.4 words at grade level 4.7. This structural disparity creates a massive gap in reading ease. Kelleher's dense delivery scores a 5.8, while Collins's direct approach scores a highly accessible 80.6. These descriptive statistics prove that politicians operate on vastly different, quantifiable communicative architectures. Their rhetorical complexity is a structural choice, entirely separate from their political ideology. This data table exposes rhetorical heuristics, tracking specific delivery mechanisms. Robert Troy relies heavily on the tricolon, the classical rule of 3, flagging 28 instances across 2 speeches. Joanne Collins uses a completely different tactic, leveraging 4 rhetorical questions to challenge the opposition directly. The pipeline also extracts meta-model surface features. These identify cognitive framing by tracking linguistic patterns like universal quantifiers and modal necessity. By counting absolute words like all, every, must, and need to, we can mathematically map a speaker's rhetorical rigidity. The pipeline also tracks representational system predicates, categorizing verbs and adjectives into visual or auditory preferences. But there is a mandatory academic caveat here. These predicate counts lack predictive validity in modern psychology. They must be treated strictly as raw lexical frequencies, not as a tool for cognitive mind reading. Computational linguists can precisely quantify the exact structural delivery a politician uses, but we cannot conflate the frequency of a word with the psychological intent of the speaker. When we pull back from the individual sentences, past the entity maps and the semantic nodes, the initial chaos of the transcript disappears. The pipeline successfully converts 52,000 words of qualitative political discourse into a perfectly structured, queryable database. We can objectively prove who is dominating the topics, how complex their syntax is, and what precise rhetorical mechanisms they rely on to make their arguments. These data points map directly back to the physical reality of the legislative chamber, revealing the true dynamics of governance. The future of political analysis does not rely on humans reading transcripts. It relies on architecting data systems capable of computing the exact geometry of legislative speech.